Hello, welcome back to the third video of the series of Let's Go with Turso. I am Meet, and in this part of the series, we will learn how to set up and run a libsql database on a local system. We'll be making use of Docker and Golang to interact with the libsql database locally. libsql is a SQLite fork. It is not a ordinary fork, it is a open source and open contribution fork of SQLite. And Turso is the platform that helps us manage these instances of libsql database on the cloud. Since libsql is open source, we can self-host it. So we can use libsql on a server, on a local system, on the using containers, or even on the edge to some extent. So libsql ships it with a daemon or server that can be used to run an instance of a libsql database on a normal machine. Just like we had an instance of database on the Torso, we can have an instance of a libsql on the local system as well. So let us see how we can set up libsql locally. So libsql ships with SQLD, which is a server mode for libsql. It stands for libsqlite daemon. A daemon is like a process which runs on the background, but it doesn't require explicit user interaction. The user can definitely interact with the daemon, but via a particular way, a particular format, or a particular protocol. In this case, SQLD will can be used as a HTTP protocol, and we can send a post request along with the statements that we want it to be executed on the database, and it will return out any rows that are returned or how many what rows were affected and how many tables were affected, those kinds of things that can be done via the daemon. Since SQLD is a daemon or a process that listens on a particular domain and a port, we can use the same things that we did to interact with the remote database, but in this case, the remote address will be just the local address. So there are certain client libraries that can be used to interact with the SQLD server. That SQLD server was on Turso. That same server could be on the local system, and we can use the same client libraries, in this case Golang libsql, to interact with the local running libsql instance. So there are certain ways which we can run and install SQLD on the system. So we can install the pre-built binary, we can use a pre-built Docker image, we can run it from the source using Docker or any other container environment runtime, or we can directly install from the source, which is Rust in this case. So let's go via two routes which I prefer. One is using a pre-built binary because it's just a single download step, and the other is using Docker, using pre-built Docker images. So let us start with pre-built binary images, pre-built binary. So we can head out to the libsql docs for build and run commands, build and run instructions, where we will find the releases for libsql, and in there we have a libsql release page. There we can find the latest releases of the libsql server itself, and we can copy the command which is using a curl to query this binary, and we can execute via the shell. So once you paste that command on the system, that should install SQLD as a binary in your system. So once that is installed, we can simply write SQLD. That will spawn up a server, and the default port is 8080. Localhost will be the domain name, and 8080 will be the port assigned for this specific application of SQLD. So to interact with this database, to interact with this daemon, so this daemon is basically spawning up a database, right? on the defined port. So what we can do is we can connect a shell to the database which is hosted on the given uh, domain and port, which is localhost 127.0.0.1 colon 8080. This will open up a fresh instance of a database. But you notice there is nothing in here. So let's create a table, a user table with the ID as an integer and a primary key, and a name, which will be a varchar of any digit, any length you want. Like I will keep it as 16. So that will be creating a user table, and then we can insert some data just to later retrieve it, just to interact with the database, query the database, or insert any rows into that. So once we insert the data into the table, we see it is returning the data from it. And let's insert a few more samples just for testing out this database. So yeah, so we can see there are 4 entries inserted into the users table. So if you want to see how this SQLD can be interacted via HTTP protocol, we can query this server, that is localhost 8080, with a post request, and body will have a content type of JSON, and this body will have a field called statements, which will be a list of strings. So the strings can be the actual queries that we want to execute. And in this case, just try out select star from users, which will give us all the rows that are in the users table. So if we run this command, we will see there are rows which are returned with the particular columns. So each list, each item in the rows list will be a particular row. So one and meat is like a particular row, with first item being the ID and the name. So let's do one by one. So let's select name from users, and you can see the column name is name, and each row will have only one field, which is the name. And so that's how we interact with uh, SQLD via HTTP protocol. So let us try out uh, creating a table from HTTP protocol. We interacted it with the shell, that is a SQLite shell. But right now, let's try it out with HTTP protocol. So we'll do the same thing, which will have statements, and we can enter in like create table post with the ID as a primary key, the title, the content, and the description as well. So you can just create what tables you prefer. So this will create table post, but it won't return anything because we have not really returned anything. We have basically mutated the state of the database. So this will say how many rows were affected or how many tables were affected. In this case, there won't be any. There's nothing returned over here. So let's insert the data in the table that we just created, which will be insert into post the title, content, and description with the values, with a dummy value for title, description, and content. So let's keep the title as a new post. So let's do this as a description, and that will be the content. And let's do also add the description as well. So this will be a first entry in the post, and so you can see there was one row return from the return statement. And let's try out selecting what we just inserted into the post table, which was just one row. So select star from post will return a single row, hopefully. So let's see. So we have ID, title, content, and description, and it has returned one single row in from the database, from the libsql local database. So here you can see data.sqld directory is created. This is not user defined directory. This is directory which is created by SQLD server itself, and it has two folders inside it, which is DBs and metadata. The DBs has a one folder called default, which has one special file called data. And if you do a SQLite 3 to the data file, you can see the schema is the same as that we created. So data.sqld/db/default/data is the database file for it is the database file which is served by SQLD as a libsql database. So SQLD is running on domain localhost and port 8080. So we can connect this database using a Golang application, just as we did before tutorials where we connected a remote database using libsql Go library. So in this case, the remote URL will be the local host URL. So we can see in the docs that we have the library which is used, libsql client Go. This will be used to connect a remote or a local libsql database. So this could be used as a domain and a port to connect to the libsql database. So we can connect we can write a Golang application to connect this running instance of this database with that package. So first we will create a struct which is post, which will be used to query out the data from the database, and write the database configurations which will be used to connect. So it will be the database URL, which will be the domain and the port, which we can also grab from the environment variable that we did in the previous videos, where the environment variable was set to the remote URL which was hosted on Terso. And in this case, in this example, we will have the database URL which is hosted locally, and the domain remains the local host, and the port is 8080, which could be changed as well. So we have the database URL configured. Then we can open up the SQLite DB connection, which will take in the parameter. So we'll first import the database SQL and the libsql client Go, which will be used to connect to a libsql database. So libsql open SQL.open will take two parameters, which will be the driver name and the data source name, and it will return the database connector object. So it will be a libsql database and the URL that we just configured. So if there are errors, we will log those out and exit from this program and close the database connection at the end of the program. So that will be the differ condition. And this open function returns a connector, database object that will be used to query the database. So we'll create a query called select star from post, and if the query returns any error, we'll log those out. And once we have the rows from the query, we'll try to iterate over all the rows, and we'll create a post collecting from each rows that have been returned and scan each row with ID, title, description, and content that will be returned from a single individual row. And once we have obtained that, we will check if there are errors in scanning the rows and then print those out. And so we'll close the row object. And so that is how we connect a remote a local libsql database using Golang. And now once we run the name, the Golang application, we Golang program, we can see we have three post objects created, and we see the local database instance of libsql. We can see that there is indeed three posts in the post table. We can also use SQLite 3 that we looked before from the specific data file that was living inside data.sqld folder. And so we use that SQLite 3 to connect that data file. We can see there are three objects of post created. So once that is done, we can now so we have seen how we can connect a libsql database using a pre-built binary. We can also that process will be similar, but we'll see with how to get SQLD running with a pre-built Docker image. So Docker image will be fetched from this Torso database container registry, Google Cloud registry. So we can grab that uh, image from grab that image from this registry and pull it in locally and run that image as a container. And so we can forward the port, which is 8080, and so we'll run the container, run the image. So we'll forward the port from 8080 to the local port 8080. So we can see the database path is iq.db. This will be used data. I'll explain that later, but you can see it is listening on localhost 8080 again. So if you see the running instances, Docker PS will list all the running containers. So if we do Docker exec the container ID and ls that, we can see iq.db is there in the system, and you can see that there is a similar structure for the database files. So if you see the data SQL, there is a similar structure for this file, and there is a data file in the iq.db folder as well. So why I'm saying this is because what happens when we run a container using Docker is it will spin up a new container each time we run the Docker run command. So that won't persist the data in that container. So if you see the schema, that is empty. So what if we want to have that users from or post from the same data that we used? We still have that data file in the SQLD, right? So what we can do is we can use Docker volumes to mount a directory into that container and then use those files as a database for that instance of that container. So it will be basically a two-way mapping of the local volume to the container volume. It will be a two-way mapping of the local real-time file which will be mapped to the files in the container itself. So we can specify, so there is a quick reference for Docker to have data persistence. So you can see there are certain commands, certain Docker bunch of configurations that we can use to run that SQLD container, um, SQLD image from the container from the image using volumes and SQLD DB path. And it also has SQLD node, which is environment variable, which can be set on the container specific environment to get the operation, the mode of the database, as well as which file to look for as a database in that container. So you can see the location of the DB file inside the container, which will default is /var libsqld, which will create that whole structure of that file structure that we saw data.sqld in the local system. So SQLD node will be the mode of database, which will be primary or a replica that can be used as the replica of the primary URL, primary database. So we'll copy the things which we need, which will be to get the volumes. So we can see data.sqld /db/default will have a file containing data that is the actual database file. And so we'll run Docker run we'll forward the port 8080 to the current local systems 8080 from the containers port 8080, and we'll mount the current working directory with /data.sqld, which is the file system that SQLD listens for in the local system, and we'll map it to /var libs/sqld, which is in the container /data as well, because that will be used to map that specific file into that system. And we'll also set SQLD node, which is environment variable for the specific container. So SQLD DB node will be the primary, because we just want to have a single primary database created. So the environment variable will be the SQLD DB path, which will be data. And we saw that data was the actual file that contained the database, libsql database, and we'll give out the final part, which is the image name. So once we run that, we can see SQLD is running, and the database path is data, and it is running on localhost 8080. So we'll see, we'll get into a shell. We'll create a we'll call torso db shell with the same localhost 8080 and try to get the schema, and you can see that there is indeed the host users tables created, and this is running on as a container and not as a local SQLD file, local SQLD daemon. This is served from a actual container. So we have seen how we can this persist this libsql database across multiple environments. Now what we want to do is we want to create embedded replicas, like just we created in the previous videos, where we had a remote URL remote database hosted on Torso, and we created a remote replica, a local replica from that remote primary database. Similarly, what we can do is we can have a primary local database, and we can create a local replica from that local database, because this local primary database won't be a local anymore when we deploy it, because it would be hosted somewhere on the cloud or on our own servers, anywhere in the cloud, or it could be even on the edge to some extent if there is a file system right permissions granted. So we'll create a Golang program to create embedded replica from this local database, LibSQL database. So first, so let's start with creating the main package and create the boilerplate, which will be the database name. It could be anything because this will be just used for local replica. And then we can import OS, because we will require to create a temporary directory, which will create a temporary folder where we specify the directory which we want to create and the pattern with which it will create each folder, subsequent folders. So we'll create libsql as a pattern, and if there's an error in creating the temporary folder, we'll log those out and exit, and we'll remove all the files, the temporary files, folders that we have created at the end of the program. And then we can construct the db path, which will be the combination of the directory, that is libsql temporary folder, and the database name, which we given as data.db. So this will create a db path. We'll use a file path.join, which will take n number of strings. So once that database path is created, we'll construct the db URL, which will be localhost 8080 as usual, but this could be from the environment variable as well. So make sure that this is set properly as your primary database URL, libsql URL. So once we have db path and the db URL, we'll import packages of SQL and libsql, go libsql, and we'll create a new embedded replica connector, which will take the db path and the primary URL. The db path is the actual uh, local replica path, and db URL will be the primary URL for the libsql database. So once we have created the embedded replica, we can we will return the connector object, and if there are errors, we'll log those out. If the connector object has returned any errors, we'll log those out, and we'll close the connectors at the end of the program. And then the final step will be to next step will be to open the uh, DB connection using the connector object that we got from the embedded replica. So SQL.OpenDB will take in the connector object, which will be used for connecting to the local replica. So we have the DB object, and we'll close the DB object at the end of the operations. Then we'll create post query, so which will be used to insert into the post table. So title, description, and content will be inserted at with the values. So let's say we have create the appropriate title, description, and content. So let's link those as the placeholder values in the respective positions. So we have the description, and the final place will be the content. So this is the entire query for creating the post object. So once we have created that, we'll log those out, and we'll sync the changes from the primary database to the local replica. So this will uh, sync up with the primary database and changes to the primary database, because we have created changes, made changes in the local database. So connector.sync will transform these changes from the local database to the primary database. So the sync object, so if there's a error in the sync, we'll log those out, and else if we have successfully synced the database, we can move forward by querying the inserted data into the post table. So we'll take in db.query, which will be used to return the rows and error object. So we'll select star from post. So once that is created, we'll log this out if there are any errors, and if we have returned successfully from the rows, we'll close the row object and then iterate over each rows. And for each row, we'll create title, description, content, and ID, which will be returned after the scan. So we'll populate the ID, title, description, and content into their respective variables. So once that is scanned and successfully placed, we will log those out, and we can do all sorts of things with this. So once that is created, this is the entirety of the program. We'll create a local DB. We'll construct the DB path and the DB URL, which will be the primary libsql database, and then create an embedded replica of, of that DB path of the local replica, and then open a connection, insert into whatever tables or whatever you want to do with the database. These changes will be made on the local replica, and then we have to sync the changes. This After syncing changes, we can query and resume the operations that we want to do in the program. So first we'll see what exactly is there currently inside the database. So we'll open a shell using the DB shell and the remote the localhost 8080. So we'll query the post object, post tables, and we can see there's just one row that we inserted into the table a while ago. So we'll run this program, and what we should see is there will be populated with the second uh, post row in the table post, and we'll run again just to get more data into the database. So we can see there are 3 entries in the post table. So if we query the local libsql primary database, we should see that there should be 3 rows in the post table. Indeed, 3 rows in the post table. So what we have done is we have able to sync up. We are able to create embedded replica out of a primary local libsql database. So we'll try it out with the HTTP protocol, and we can see that there are 3 rows being populated. So from this video, we learned how to set up SQLD server locally, then consume this SQLD server via the HTTP protocol, use persistent volumes for serving SQLD locally with Docker, connect locally hosted libsql database using Golang, and create local embedded replicas from a local primary libsql database in Golang. Thank you for watching, and see you in the next one.